Hi everyone, my name's Andrew. I'm currently a senior at Duke, and I'm making this video right now to show you guys how a breadboard works. Thanks everyone for watching. Hoping everyone is having a good quarantine and you're not quite as bored as I am. And just remember throughout the course of this video that I only learned how a breadboard works or how any of these circuit components worked when I was about 18 in my first year of college. So if you're watching this before you're 18, you've got the jump on me and you're probably going to be a lot smarter than I am one day. So just to walk you guys through what a breadboard is, a breadboard is a circuitry device with a lot of wires. It's made of plastic that's used to prototype a circuit. And what that means is it means it's used to test a circuit. So if you want to make something, say a computer, say a battery cell, anything that has a lot of different wires in it, instead of building it right off the bat, you're first going to build it on something called a breadboard. You're going to see how the wiring works. You're going to be able to make mistakes. And then you're finally going to build it in its final form. So a breadboard is sort of a way to test the circuit. It allows you to make a lot of mistakes, do a lot of things wrong. And it looks a little bit like this. So I have a Tinkercad version of it up right now. As you sort of drag around, this is a 3D model of it. From the top of the breadboard, you see all these little holes like this. This is a hole, that's a hole, that's a hole down there. And all of these holes, a wire is going to go into them. So say you want to connect this hole to that hole, you're going to put a wire in here, you're going to drag it all the way out there, and you're going to drop a wire in there. So it's a little bit of a rectangular box like this. You can see what it looks like under there. This is what it looks like in a 3D model. And I think I have a picture on my laptop. This here is what a breadboard is going to look like when it's actually wired. So you can see if you wanted to say connect that hole and that hole, you'd have this big blue wire that goes and connects them. You can jam a whole bunch of circuitry components into it. And this looks a little crazy and hectic. You've got resistors here, you've got LEDs here, you've got what looks like an op amp there. You guys don't really have to worry about all that. All you have to know is that this is what a breadboard looks like when it's wired in real life, because we're going to be doing it online today. So that's what a wired breadboard looks like, just to show everyone. And now I'm going to show you how a breadboard works. So I have a picture of a breadboard here. The first thing that we have to know are what the rows and columns of a breadboard are. So everything with a number here, this is the first row, second row, third row. You see 5, 10, 15, 20, 25, 30. These are called the rows of a breadboard. So this is going to be row number 1. See how there's a 1 there? That's row number 2. This is row number 3, etc. You can see my paintbrush going along it. Everything in one row of a breadboard is going to be connected together by a wire underneath the holes. So I have a little green paint that I'll paint over here. That means that all of these holes are connected to one another by a wire underneath them. So if you connect one wire to here and you connect another wire to there, there's going to be a little metal wire running underneath these that connects all of them together. So all of these holes are going to be connected. All of these holes are going to be connected. All of these holes are going to be connected. And that didn't quite work because my mouse is a little broken, but etc. It goes all the way down the board. So that's how it works. In the same way, all of these are going to be connected. It's important to note that there's this big divider here. So I'll switch and make it black. This divider is going to cut off any of the connections that I just talked about before. So what that means is that these are all going to be connected, but this row is not going to be connected to that row. So this row 1 and this row 1 are different. So say you plug a wire into here and you plug a wire into there. Those wires are not going to be in the same node. They're not going to be connected by metal because there's this big divider in between them. So think of it as two halves of one big breadboard, where over here, this is one half, F, G, H, I, J, A, B, C, D, E is the other half, and the halves never connect unless you actually make a wire that physically connects them. The other thing about a breadboard are the columns. So we have column A, column B, column C. The columns go all the way down and they're the longer part of the breadboard. So the rows here are going to be shorter and the columns are going to be longer. The columns of the breadboard are just sort of there so you know where everything is, so you're more able to organize the work you're doing, but the columns are not connected. So this and this are not connected. I'll actually erase that just so everyone remembers that. And that actually makes it black. I'm a little bit new to this software, so we'll say black means not connected. So what I'm trying to say is that here and here are not connected. Only here and here are connected. So between different rows, there's no connection, or along a column, there's no connection. The one exception to that rule, and what makes this a little bit complicated, is that we have these positive and negative columns that are in fact connected. So what I mean by that is that on the left and right side of the breadboard, you see that there are these two long columns that don't have letters on them. They actually have positive and negative. All of those, instead of being connected crosswise like this, are going to be connected in the other direction. So they're connected this way, which means that the entire column, like this, is connected. It means this entire column, just like that, is connected. That entire column, just like that, is connected. And in the same way, that entire column, just like that, is connected. So if you put a wire here, and then you put another wire there, there's a little metal wire running all the way around here along the little green paint I've drawn, connecting the two together. In the same way, this little dot here and that little dot there are not connected. I'll draw a black thing to make sure everyone understands. So in this portion, it's the opposite of what it is in that portion. I understand this is a little bit hard to grasp, especially with my bad painting skills. So Tinkercad, which you're going to be using later when we actually wire a circuit, has a lot better of a graphical and sort of visual understanding of how this works. So you can see that when you have a breadboard example up in Tinkercad, I'll show you guys how to do this a little bit later. When you hover your cursor over any little dot, it shows all the dots that it's connected to. So we'll take a look at this. Just like I said, when you hover your cursor over here, all the dots that are green down here, 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 and here, they're all connected to this one dot with a wire. All of these dots are connected, all of these dots. Remember that along this little border in the middle, none of the dots are connected. So all of these dots are connected, all of these dots are connected. Now, if everyone remembers, when I put my cursor over here, all the dots in the other direction along a column are going to be connected, not along a row. So that's something important to remember. You guys can sort of play around with this. This is in the Tinkercad Circuit Builder, which I believe will make a video to show you guys how it works. That's how everyone works there. Just to show you guys that there's no funny business. When I run along here, it's the same thing. When I run along there, it's the same thing. So what I'll do now is I'll ask you guys a little bit of a question if you worked with breadboards before. If not, it'll just be a little example. My question for you guys today is, how would you build this circuit on a breadboard? This is going to be a voltage source, so a little bit of a battery source, and this is going to be a resistor. So what we want to do is we want to take this voltage source, probably a battery, or in our case, it's a solar cell for later on in this lesson. We're going to want to connect a metal wire all the way around here. We're going to want to connect it to a resistor over here, and then we're going to want to connect it to the other end of the battery. You guys go ahead and pause the video. I'll take just a second, see if you can figure out how to wire it, or see if you have any ideas for how you might want to wire it, and I'll come back in just a second and tell you how to wire it. Okay, so hopefully everyone had their time, or they just sat there in awkward silence while I went ahead and talked about that. Let's take a look at how to build that circuit in a breadboard. So the first thing we're going to need is a power source. Let's use a 9-volt battery, just like this. I'll go over in a little bit more detail how to do this later, but what we're going to want to do is we're going to want to connect one end of the 9-volt battery to, let's do this positive lead here. So it's important to remember, we'll make this a red wire, just so everyone knows, that this wire now goes to this part of the breadboard and it's connected to all of these circles here. So if I connect a wire to any of those circles, it's going to be as if it was connected to the positive end of this battery, indicated by the red wire here. Now we're going to connect this black negative wire to this part of the breadboard, this negative end, and we'll make that wire black, just so it's clear for everyone, and we'll drag this battery down a little bit. Maybe not, just so everyone understands. So this wire is going all the way over here, connected to the negative end. This is sort of the convention or the normal way to wire a breadboard, which is how I'm teaching you guys that way, but you can do it any way you want. So the next thing we're going to want to do is, now that we've got the battery hooked up, we're going to want to hook up the resistor, right? So what we'll do is we'll find the little resistor icon here. There it is. And we'll just put that right there for now. So what we want to do is we want to get this positive end connected to one of the ends of this resistor. It goes through the resistor, and then it goes in a wire to that negative end. Just like positive end, through a wire, one end of the resistor, through the resistor, in a wire to the negative end of the battery, right? One of the best ways to do this, and probably the easiest way to do this on a breadboard, is, let's go ahead and rotate this resistor a little bit, and we'll make this resistor 100 ohms, just to be consistent with the diagram before. we'll just drop this resistor right in over there. And I'll show you guys why I'm doing that in a second. But what we're going to want to do is connect the positive end of this battery to that resistor. But because we can't actually tie the wires together, the next best thing that we can do is connect it to the same row that that resistor is connected to. So you see how if we connect that wire there, it's connected to the same row as resistor. Let's go ahead and do that. And let's go ahead and connect the negative row of that, the negative end of that resistor, or the end of that resistor, to the other end of the battery. So this wire is wired a little bit weirdly, but just to show you guys how this is going to work, what's going to happen is power is going to go, or electrons are going to go from the battery to the positive end of that battery where power is coming out from, all the way over here. It's going to flow across that little green box line to here. It's going to flow over here. Then it's going to be able to flow up there. Then it's going to go all the way across the resistor to here, to this row here. And you see how it can go to that wire, all the way over here, and then all the way over there. So that's sort of a rough idea of how to wire things in series in a resistor. It might be a little bit, in a breadboard. It might be a little bit complicated. So we have some ideas of people explaining it maybe a little better than me in the description below. After this, we're going to build a solar cell. Once again, my name's Andrew. Thanks so much, everyone, for watching. Hope you're having a great quarantine, and we'll see you in the next video. Thank you.